All right, everyone. So let's get started with some of the demos that I have planned, so we can talk about a little bit of the state of tooling in Teal and things that have been done in the language since the last meetup. Let me share my screen here. An interesting thing is that I have been mostly I have been essentially working on the core compiler, and it's my main focus of interest. But we have had folks in the community who have been working a lot on the state of the tooling, and this is super interesting, and I think it's a really great arrangement for cooperation and in getting the project forward. As I always say, it's like the tooling is just as important in a modern language as the core compiler is. So let me show you. This is work of from Patrick, who maintains the. I'm not really a Visual Studio Code user, so I just have it here so I can demo it. So he has here. So Patrick has installed the Teal language support. He has developed the Teal language support extension. So I have it installed here. And so let's see what does this gives us. So right out of the box, we can see that it gives us things like this is the Teal source code. Let me find some function calls and things like that. So here, if I hover over the function calls, it gives me the arguments and return types. So here, like a function that takes a type, returns a type. Here's another function with all of the types, and here are all the types of the arguments. If I go in here, and it also gives us in the current release, it also gives us autocomplete with the proper types. So here, like node is detected if we have node types. So these are the completions for the node type specifically. And so if I go here for the type, for example, it gives us the completions for the type, which is different from node. So you can see this is pretty snappy, really cool. And let me see, take care of if I go here, node error, then we get the then it gives us the function types, and we can look up the things that are in the current environment, right? So if I go here, you can see a meta method, it's in scope. It gives us out all of the names that are currently in scope. I think if I go here and do see here now ZZZ is in scope, so it appears here. So yeah, kind of cool stuff that you expect for a modern language environment, and especially things like this, which actually require type knowledge, right? It's not just something that, for example, a Lua environment, a pure Lua environment could not give you this without the type information, right? Because otherwise, if node, in pure Lua, node would be just a table, and a table can take any kind of value. And as you can see, as we type, we also get the indication for errors. So here I had made I've created this function here, but I did not. Let's see, what's this one? Let's see if I pass a wrong argument here. Let's see what happens. Yeah, it's complaining here that type is not a node because the argument 1 expects it to be a node, but I gave it a type, so we get an error. Also here below, we get the summary of the errors. And it's interesting that when I opened this to prepare for this demo, and it had an old version of the compiler source code open, right? And there's an error here. And this is interesting because this is also a little bit of a language update, in that this error, if we jump here, you see it's complaining about this field here, right? Saying that in this map, the string enum item is not a valid member for this map because it's not a member of type name. Because here, all the keys have to be valid type names, and here this one is not, because type name, if we go all the way back to the top of the file, we'll get the list of the valid type names. Where are you? Here. So these are the internal types that the compiler uses. And if you go back there, like to see that this is not a valid. And in the old version of the compiler, Teal, like a month ago or so, like Teal did not complain about this. And the reason was interesting. It was because the resolution of types always happened from like the inside out, right? And when you get here, it would say like, okay, this is a Boolean and this is a string. Because when you just look at this without context, it's just a string. So what it resolved this, it will resolve as like a map of strings to Booleans. So when we get to the point of this assignment, the information about the exact strings was already lost, you might say, because all it had was a map of string to Boolean. And here it wants a map of enum, which is more specific than string, to Boolean. And because we did not have a way to do this matching, the compiler would just accept it, right? So so essentially it was treating, like in technical terms, it was like treating bivariantly the relationship between the strings and the enums. And now in more recent versions of the compiler, the language, we have I have fixed this. And the way of doing this is through a bidirectional inference. So now whenever you put a literal table, like something with curly brackets in a context, for example, here the context is an assignment. If the other side of the context, for example, the declaration here, has an expected type, this expected type will be matched outside in here. So it will say like, okay, I want a map. So, okay, this looks like a map. And then all the keys need to be type names. So it checks the keys and then it checks the values. So here is why it is detecting this error. And this also happens in now in function arguments in any context that you have, that you know the type beforehand and you want to put the value in there. So now if we delete this, now no problems have been detected, right? And sorry, any question?
Magic.
Yeah. So yeah, so this is really cool. The kind of integration that's happening here. Like this is actually like more advanced than even what I am using, because I'm using my clunky terminal editor to edit. So if I go here, I have put a little bit of that level of detection here. So like say, let's make an error here and save. Now my editor also like gives the error message here, but it's not as nice as the integration that Patrick has made for Studio Code. And in mine, I don't even have the completion yet. So this is like, and an interesting thing is like how this works, right? How does the Visual Studio plugin get the data that it needs, for example, to do that completion, right? Here, like visit type, dot, and then it knows that after allow missing CBs and CBs, for example, here, right? And CBs has after and before expressions. Like how does it know all of the data to do this, right? So for that, let me see if I can. Let me get a big terminal. So for that, we have a new command in the Teal command line that's called Teal types, that gives you the type information for a given file. So this is something that I have added in the compiler to provide the information for the editor plugins. So so what it is producing a JSON file with a table with a series of data. For example, the table of like, these are all the globals and these are all the, I think like, this is like the table of symbols, and let me see. This is a table like by position, like in this file, in this line, in this character, we have a type number 6. for example, and if we go to types, then we have a table of types, right? So the type number 6 is an enum, and with this fields, for example, off, optional, and required. So when you get there, so by tracking down, by following through the references in this JSON file, the plugin has all the information that it needs. And I provide and as an example of the use of this JSON, we also have, we can give information of all of the symbols visible in a given position. So I don't know, let me give like a random line, like, okay, in this line of the program, these are all the symbols that are visible and their types according to that full table. So essentially what in the background, what the Visual Studio Code extension is doing is that every time there's a change, like it gets the full table of files, and as you go through the file doing completions and stuff, it does the equivalent of this. So essentially the operation in .p is essentially a filtering over the full output, and so there's a function called symbols in scope that does like oops. The editor is. So there's a function symbols in scope. Essentially, it does like a binary search and gives you the list of the symbols in scope. And Patrick has reimplemented this function in TypeScript and in the plugin, just so that it gives the same result that you get here. Right. So he has given me like lots of feedback about bugs in the output of TL types, even because he was using that, and I am using that, and I'm using the same thing. Like this is using TL types as well to produce the errors and to produce the type information. For example, here now I have the file saved. See, like as I walk through the file, it gives me like all the type information for everything. So like binary search is this function, symbols is this, like is array of the tuple of number, string number. And so this is using the same information that the TL types, it's using the same information that the Visual Studio Code is using. And we have, and I believe like in Quarry, let me find that. And if we go to the Teal language org on GitHub, let me find that here. You'll see that we have here we have the Visual Studio Code plugin, and we also have this in the works, which is kind of the same thing but more generally, a language server protocol server, right? An LSP server. So this is the same kind of thing that Visual Studio Code supports. And this is written in Teal itself. Corey has been working on it. So just Euclidean ACE on GitHub and in the Gitter chat. So he's been working on this, which is sort of equivalent to what the Patrick's plugin does. But this is going to be editor agnostic, right? So we have like Vim and Emacs and like Atom, like a bunch, I think Atom, like a bunch of different editors and IDEs nowadays support the language server protocol. So once this gets stable, essentially like all of the modern editors will support the same kind of stuff that VS
Hisham, am I understanding correctly what the current Visual Studio Code extension is not using language server at all?
I think it's implementing. Yeah, I think it is. I think it implemented by itself. So I'm not sure exactly the internals how they look like. It is written in TypeScript, and it uses it talks to the TL compiler, right? So it will probably probably there will be some reuse of the logic and some collaboration between these two, and probably eventually a future version of VS Code Teal will probably use the Teal language server. So So that's one thing which I think it's kind of a game changer for working with Lua code bases, especially with large applications and things like that. I have seen the trouble that people who are new to Lua or new to a large application get when trying to figure out where is everything, and having clear types and an understanding of what is what, like here, like unresolved, what is unresolved? Oh, it's a type, right? And so we know what we can do with it. Okay, what is nominals? Oh, it's a table, it's a map of string to arrays of types, right? So here I can put that in the type. So it makes it a lot easier to understand the code base. So having this kind of information. So I think this is really cool and something like that's going to be, as I said, like a game changer for TL as a whole.
Yeah, absolutely.
Yeah, something. Any comments or questions at this time?
So I'm curious, have you been converted to a happy VS Code user instead of Vim?
Yeah, so that one in the terminal is not Vim, is a text editor that I wrote myself a long time ago.
Okay.
So I am a little bit married to it because it like all of the little quirks, I put them there, so I'm so used to it. But yeah, I was very impressed, and I have considered switching. Like a friend of mine, like 20-year Vim user, has recently switched to VS Code. So we were talking about this, but right now, like I think it's kind of like it's not even the plugin. I think VS Code is kind of like a bit slower in my machine than because it's this big JavaScript application. Than mine. I noticed the difference when I'm working. So maybe that's the one thing. Like maybe I need a faster computer to use it. but it is pretty nice. I am very impressed by it.
The next question is Teal Debugger.
Teal Debugger. Yeah, that's a great question and something that I've been thinking about. And I think that once like there will probably be the next step in for this kind of editor integration. I don't know if the language server protocol has a protocol for debuggers.
No, it's not for that purpose. No.
Right. I think I think they were talking about making a debugger protocol. So that will be interesting. I have seen
there is a debugger adapter protocol,
but not as part of language server.
It's parallel, but VS Code supports it.
Yeah, absolutely.
And it's the same idea, basically.
Yeah, so I think that would be what would make most sense to support. And probably the way that I would like to see this, it's something kind of like what we did here with the editor plugin and TL types, right? Like some level of support provided, like the low level support provided by the core compiler. And then some high level thing on top, like the debugger adapter or something like that. I don't think it would be very hard to adapt existing Lua debugging tools for it, because right now, like our files, we generate files that are the line numbers match. So generally, like I think breakpoints and those kinds of things would work the same way. And we are exporting all the type information right now for the symbols. So I think it's more a matter of integrating things that exist, right? I think for now to get a Teal debugger, I think would be now more a matter of integrating lots of things that exist, which is like the exported type information and the Lua debugger, and possibly editor support, because I think there are Lua debuggers in the VS Code marketplace based on there was an old project called Rem debugger, which was a remote debugger, And usually you need to like to put an extra line at the top of your project and then build again and then start a little server that talks to the other side. Like the Teal could probably make that more automatic because we actually generate Lua, so we could like if you start in debug mode, we could generate that line for you and you could run that. So it could probably made a little bit more automatic. But yeah, I think I think it's a cool project, like in search of someone who would take it, right, to make a Teal debugger. I think it's very possible based on things that exist. So but I'm as for me, I'm focusing on the core compiler and the core language, getting those bugs fixed and providing, providing those hooks and that information for whoever wants to write the tools. And it seems to have been working well as this model. So I'm excited to see the results that we're getting. Yeah. Anything else on the topic of editor support? All right. So yeah. So let me skip then to the second topic, the second demo that I had to show, which is another project here that you will see in the Teal language repo, which is Cyan. And Cyan is the Teal build system and project manager. So what is that? So this is a new project that again Corey has been working on, and I think this has a lot of potential for making people's life a lot easier and getting a better, like an easier jump start into using Teal and all of that. And I will explain better. So first, I'm going to just start with a quick demo. So this is Cyan, like Teal, Cyan. Like I suggested we go with the colors theme, and I think they are kind of like similar colors. So yeah, so if you run Cyan, it tells you that it needs a command. And I think .h will give us more information. Okay, so here are commands: init, initialize Teal project, build, and the other ones look very much like the TL command line command line tool, right? So at first you can think of Cyan as a supercharged TL command line tool. And the reason we were talking about having this project as a build system of its own was because originally TL was this very simple Lua script that would just load the compiler module and call the functions to write a file and do simple things like that. Like the very first version was just like tl.tl. There was not even commands or anything. So then we started, okay, let's make a difference between check and generate, and then like, okay, let's do both and check and all sorts of things. So at one point, Corey contributed TL build, which was this like a lot bigger command that does a lot more than just compiling a file. It actually it scans through the directory tree, and you can have options in the TL config.lua to tell you exactly to configure how to do a build and all of that. So at one point, I think at one point it was like a third of the whole TL script was just the build command, and the rest, or even more, I don't remember. But at the same time, once you have such a powerful command, you want it to do more and more, right? Because it essentially becomes your build system, right? It essentially replaces makefile, and you want it to be smarter, and you want it to be more efficient, and all of that. So next, we had another contribution asking for okay, let's have build.tl files, which is like build.rs files in Rust, so you can run an arbitrary script when you run a build and all of that. So and there was all these ideas floating, and so the impression we got was that the script would just keep growing and adding more stuff. And then it wasn't not very clear, where to draw the line, because at one point, when it starts looking more like a complete build system, kind of like starts looking more like you can take, for example, in one extreme, you can look at, for example, Cargo for Rust. It is essentially like it's a build system. It's like a package manager. It's everything all in one. It gives you a very very nice experience, but then it's like it's something separate from Rust C, which is the Rust compiler. Right, which is more like GCC, like here's the input, here's the output, and do that. So the question was, okay, like I think we need to keep the core compiler minimal, especially because like not everyone's going to need the build system. Lua and probably Teal is going to be used a lot in like embedded into other projects, and sometimes these other projects, they have their own build systems already in place or their own tooling, and right. So one of my goals was to keep TL very minimal and very generic, and even more so the TL.lua, right, the TL.tl, so that could be embeddable and just play nice with whatever environment showed up, right? So at that point in the conversation, it was like I think we should just make this a separate project, so that the people who want to have it, like with all of the bells and whistles and like all of the facilities and the niceties, and could have that, and not be restrained by the minimalism of the main compiler project and all of that, right? So kind of like, so it made more sense to have it be its own thing, and yeah, and I think it's getting like really nice results, because now you can have like it can be like. Can be a little bit more opinionated in the sense that, right, here's the init command that initializes a project, so it just already creates a configuration file for you and a set of folders, and everything's already set up so it works, well configured together. So it's just like things to reduce the barrier of entry and the learning curve, right? So here's and the point where we decided really that this was to be able to go was the point where when Corey was adding like this other feature, which I will demo here, which is really nice, that Cyan has and that TL build does not have. By the way, we're going to deprecate and eventually remove TL build, so that people who want the all-in-one build command should just use Cyan, which should be like installable the same way as TL, just like Lua rocks install Cyan and you get that in your command line. So now if I run Cyan build here, I just ran that, and whoops, nothing happened, right? And the reason nothing happened is because the project's already built. So one thing that Cyan has that raw TL, the command CLI, doesn't have is incremental builds, right? So if I go here and make a change to the source code of Cyan, because here I'm in the Cyan project, it's essentially building itself, right? So if I go here and make any change, now that needs to be compiled, right? So now when I run that, it type checked and it generated the new output. So is that working? I think it's getting from a different folder. So but it did compile that, so it's probably here. Yay, demo gods. Oh no, it's writing to TMP. Okay, so it doesn't. Okay, okay.
And how do we control it?
Yeah, the project is configured. The project is configured to build into TMP so that it doesn't break itself, right, when it's under development. So that's why. So if we go here to TMP CLI, so here is the output with the changes, right? So that's behaving correctly. I was not aware of I forgot about but the output did tell us that, right? That's how I figured out, because it had like nice color informative output here of what was going on, right? The input file that was checked, the output file. So it's and then there's more stuff here. And now if I run again, of course, it's real fast. Nothing happened because it's already built. So if I go there and edit again, and do that change. And now let's make an error here. I'm gonna create an argument here that doesn't exist. Well, my editor has already picked it up that it doesn't exist, right? But let's try to build again. So here we get an error, and as you can see, Cyan produces a lot nicer looking error messages than Teal, right? Syntax highlighting right in the error messages and the locations, and here's the information, because what the core compiler gives, right, in its API was like it gives you the file name, the location, and the message, and here from that information it builds you like a nice looking error message, even like pointing to what's wrong, right? So this is, this is in line with what modern compilers and modern build systems produce, right? If you look at modern, various other current languages. So this looks really nice. I see a question in the chat. So it says like, so if I just want to compile my TL files into Lua files, do I need two files, TL and Cyan? Well, if you want to do like build in one command, right, that's what we're going to recommend for you, because TL will continue to exist, but it will be like the simpler thing that does like TL check, TL gen. Like if you're having one file, like to generate one file at a time. For example, if we go to the TL project, right? So TL just compile itself. You can just use this, right? And so essentially, Cyan is it's like your it's like Make. It's a build system, right? That with all that extra knowledge about like looking at the files, comparing the timestamps, seeing like, okay, the output file is the input file is newer than the output file. I need to generate that again, right? So all of that logic, it's out of the compiler because it's really not, it's not its place, right? Not in the core compiler. So again, this is it's just like Make and GCC or Cargo and Rust C and.
What about LuaRox?
Yeah. So yeah, good question. What about LuaRox? Yeah, because this is like before Cyan even came along. I was my original plan was essentially to put some level of TL support in LuaRox, so so it could do that. But LuaRox also does not support incremental builds and all those nice things for development, right? LuaRox can do, like LuaRox is generally geared for deployment, right? And I could totally see, like then I will not promise features for Cyan because I'm not gonna put words in Corey's mouth, but like once you have like these things that's like, for example, Cyan could probably be able to generate the rock spec or something like that because it has all the information about which files were generated and those sorts of things, right? So, or for example, we could add like easier still, we could just add this is sort of already possible in LuaRox because LuaRox has a raw command mode in which you say like to build, run this command. So you can make a rock spec that runs Cyan and builds everything and gets it installed, right? Maybe it could probably, if you would do it today, it would probably be verbose. You would probably still have to list the modules and something like that. But we could make a build backend because LuaRox is extensible. You can have different build backends. For example, if you there's a new backend that was made recently for Xmake, which is this Lua-based build system. So yeah, you can if you use Xmake as a build system here, there's probably going to be some example here.
Well, in majority of the case, CMake would be the case, and we would need to handle all this stuff ourselves, like finding Teal, running Cyan, whatever. That will be.
Yeah, for example, this is essentially the LuaRox plugin for using Xmake, right? So the way you use it is like you put that in your build dependencies saying that you need Xmake to build, and then you just say Xmake here. So it would be just as easy to make For example, a Cyan-based plugin for LoRock. So then you say like Cyan, and then it figures out, and you don't have to put all of the files in the rock spec anymore, for example, right? So yeah. So that will be possible. I think it's so yeah, there's a comment in the chat that said, yeah, for example, Jan is okay. Like if you want to use Nix to build things, right? For example, yeah, you can. That's why we wanted to separate the compiler from the build system. If you want to use your own build system, something else, to deploy, then you can, right? And it's nice to provide the nice thing as an option for whoever wants to use it. And yeah, and Cyan is looking rather nice, and I expect it to catch on. That's why I wanted to bring it up here and showcase. I think we don't even have a stable release yet because the Teal API has been changing and updating. But probably for the next release of Teal, we'll probably have a release of Cyan that goes along with it. Probably like the first stable release, because now we're at the Teal 0.12, so probably around the Teal 0.13, we'll probably get that. So I have been already testing Cyan with the latest changes that we're doing in the language. So namely the integer support, and things are looking fine. Like yeah, to give an update on the changes on the language. So this kind of also inspired by Cyan and such. Here's some big, like nothing very visible for end users. And okay, here's the question: is the nice error output hard to make? I think it would be better to have it in TL directly, even if without syntax highlighting. Yeah, so that's the thing, right? Everyone wants some feature. Some people would say, oh yeah, I want the build system even if without incremental. Yeah, I would like the nice errors even if, so like everyone wants a different 10% of Cyan into TL, right? So it's better to just take everything out, keep it minimal, and because right now I think like I did not put a lot of, and this is like very personal opinion, like I have not put a lot of effort into making nice looking error messages. Like I've been paying attention to the text of the messages, like the content, which is the same thing that Cyan uses, right? For example, we recently had a comment in the chat that someone was confused about like a module not found error message, when it was not the case that the module was not found. The module existed, but there was no type information. This is something that I think the compiler needs to fix. And I want to make a better error message for that. But like the output and the looks, because in my mind, I always thought that this would be fed into other tools, right? Like I nowadays, because I have the error messages right in my text editor, like I don't even look at the output of TL myself usually, right? Because if I made a, if I go here, if I make a mistake, I see it. Like if I make a mistake here, I'll say I see it immediately. You just say, oh, I can't mix, a number or a string here, right? So that's how I look at the error messages myself, right? It's via editor integration. So, but different folks, will use things different ways. So there will be a bunch of like API cleanups here, but I don't think lots of people are using these APIs. They're not very stable even. And so Corey has been wrapping things in Cyan to deal with any API changes. And well, they told me that it won't be too much trouble to get this more merged. And the last thing I wanted to talk about is the integer type. So yeah, this is the one thing, like it's still in draft because it needs more tests written, but I think it's the big thing that I want to merge in 0.13, and it was like the thing that was at the top of my list and in the FOSDEM talk. So yeah, so now integer is a new type. Important things about it, like if you just type an integer constant in your code, it becomes type integer. The logic for preserving the type, they follow Lua 5.4 semantics. So like if both types of the operators, like if both operators are integers, the result's an integer. If one of them is a number, the result's a number. Number is the existing number type, which is floating point. There are subtle things that, like in Lua 5.4 semantics, like the integer division, if you do integer division of two floats, the result is still a float, even if, but you will get the integer result, like .0, right? So it's preserving that. So like if you want to convert to integer, then you have to do something like math.floor, and then you get an integer. Integer is accepted everywhere a number is expected, so no surprises there. But if you type local x equals 1, it becomes inferred as an integer. So then if you try to do x equals 2.5, you get an error. So if you want to infer a number, you put like 1.0 here, or you just say local x colon number equals 1, then it will work as a number as well. Yeah, so if the type is assigned as an integer, for example, if you declare in your function that you only take integers, then an arbitrary number is not accepted. You have to do like math.floor or something like that to convert, right? Or as a cast, but then like, okay, of course, casts escape the type checker, right? So I have put the annotations on the standard library, but only in the returns, because generally the standard library always accepts floats everywhere that it expects a number, an integral number, even if it's not a true Lua integer, right? So for example, you can do, here's an example. Like if you do table insert t 1.0 hello, that still works. It will put in position 1 of t, right? Because this is how the Lua, in order to reduce the compatibility issues when integers were introduced, this was kept this way in the standard Lua library APIs. So we're keeping this in the standard Teal APIs as well, of course, for matching. So when I made changes in the compiler itself, for the Teal internals, I have changed the functions everywhere to stop using numbers and start using integers, right? Like all in my record types everywhere, right? So that forced me to pass integers everywhere, right? But as you can imagine, a compiler does not do a lot of numeric operations. So essentially, once I changed everything to integers, everything just kept working. Here, for example, like all of the indices, the locations in the parser, they were all changed to integer, and everything just kept working the same way. In fact, I think there's only one place in the whole compiler where I store floating point numbers, which is this variable const num, which is where I store the constant value of, if you do something that's like a table that has a key that does this, right? And this is done so that like I can do an error if you try to do this twice, for example, right? Because that kind of stuff. So I can detect so otherwise the transition here, like the transition was rather painless in the end. So I don't really expect it to be a much trouble to whoever has like existing Teal code to switch to using integers. Like you will have a couple of errors. Like usually what will pop up is that like if you have things like like local x equals 0, and then you have another function somewhere. If you have another function somewhere and it says like return number, right? And you're returning a number, and then you do this, right? I should have been doing this. Yeah, so this will cause an error, right? Because x was inferred to be an integer, and f is returning an arbitrary number. But really, Hi there, Corey. But really what's happening here is that this, well, this is actually an integer. So one easy way to fix this is just to say like, oh, this function is only returning ever integers, right? Or if this could really be a number and this annotation is correct, then what you really need to do is just say that you're in floating point, right? And then this is not an error. I've seen chat several questions. What do you do for LuaJIT? Do you plan to support the parser LL and ULL for integers? And do you think you're going to do anything for type inferring? Those are great questions. I have thought about that. I have thought about the possibility of actually generating like LL in the output code for integers in LuaJIT explicitly. So we could say that integers in Teal have 64-bit precision, whether you're in LuaJIT or whether you're in Lua 5.3, 5.4. That would be nice. However, there's a big limitation in LuaJIT 64-bit numbers, which is the fact that they don't work like numbers for array index. Yeah. Right, so that, so if you put like, so if you do this and then you do this, you don't get the thing back.
Actually, right? I think this is the biggest bug in LuaJIT compiler because, well, it's just making no sense at all.
Yeah, so yeah, because this is a boxed number, and each time you create a boxed number, they look different. So one thing that I have, like, I don't have a use for this, and I'm not sure if there will be I'm not sure if there will be demand for it, and who knows, if someone really wants to sponsor that feature, then I could do some consulting work, I think, I don't know. But one thing that would be possible, for example, would be to add an integer 64 type, right, that is explicitly known to be 64-bit, but then it's not allowed as a key, for example, right? And then it would say like, oh, if you want to do calculations, you can move to an integer 64, keep your precision, and then, stored like do to number, like say, for example, if we had the special value, like that was like integer 64, then I could generate this as this in LuaJIT, right? Yeah. And keep the and have all the calculations work because we can keep the types easily in Teal, keep track of the types, right? Then if you do like v plus w, like all of that, right? But then the Teal compiler could easily protect you from this bug, right? From this problem,
yeah.
Right?
Yeah. Yeah. Here's the case one. I assume we have a lot of LuaJIT code which is which have a lot of ULL suffixes here and where, and we start to gradually migrate to Teal, function by function. And I think what parser at least should allow these suffixes.
Yeah, because that's a tricky one. That's a tricky one because those suffixes are like LuaJIT specific, and they say something about the precision that not every Lua version can support. So it could, like, it could end up like rather it could end up producing like rather puzzling results. So for a general language feature, like if this was going to happen, I would probably rather have it as an explicit, like explicit language feature with known limitations, such as like an explicit integer 64 support. But I think for now, like for like Teal 0.13, what I have in mind really is this PR, which it essentially like it allows you to keep track of your integer values, right? Which for Lua 5.3 and onwards, it gives you some that translates into some precision guarantees. But as far as Teal is concerned, the precision is arbitrary. Like it's kind of like it's unspecified in the language. Like sort of like in C, if you type like int, you're not really sure because, like on x86, this is 32 bits, but like in the alpha, this is 64 bits and something like that, right? In different processors. So so for now, we're making the first step into having an integer type. But yeah, like the logit specifics are tricky and something really to think about. But yeah, but having the difference between like the code that you write and the code that you generate, at least it opens the door to allow for, for this possibility. So no, it might maybe a compiler flag, something like that, right? And yeah. So yes, so this is coming in, and I think these are the two big upcoming things, like this, the integer type, and the API cleanups. When these get merged, we're gonna get Cyan fixed up to make use of that. And yeah, once we'll probably get the next release of Teal with the first release of Cyan, and then at that point, TL build will be deprecated, and eventually people using TL build will migrate to Cyan build, which is going to be like pretty seamless. Well, it's just the demo that I gave earlier. I think Corey, you joined late. I did a quick demo of incremental build and Cyan, and it's just going to work just like TL build but nicer. So yeah, so this is all I had for today. We're already a bit on time. So and let me stop sharing screen. I talked a lot today. So anyone else has any other questions or comments?
It's absolutely exciting to see how fast you could move to all the different locations, and it looks like ecosystem is starting to grow and producing some fruits. Very nice, very nice. Well, debugger would be the next big goal, I think. Well, by the way, and please still not forget about the simplification of generating of documentation.
Yeah, those are two things that would be great to see. And again, as I said, I think the model that we have started doing with like the TL API that Cyan is using and TL types, which the editor is using, which were the two things that I demoed today. I think that model could work really well for documentation generation, which I have made an experimental branch for like preserving the comments in the AST. So probably a documentation generator would use that. And like if someone would like to work on that, that would be a great project. And again, like I gave like a rough outline earlier of how I could see a debugger working out with combination of some like the debugger adapter protocol, an existing load debugger plus the TL types information. I think with those three ingredients would be like most of what would be needed to make a TL debugger. And yeah, and the other project, and again, like a plug that we I forgot to share screen for this. Let me show that one last thing is that Lab Lua, the Lua Research Lab at PUC-Rio will be in Google Summer of Code this year. So we'll be looking for students to apply. And I'm a longtime collaborator with the lab, and folks have graciously like I got involved this year with their org, since Lorox is not participating this year. So I have submitted at least one project here, which would be the idea of starting to have some typed API for Lorox, so that Lorox could be controlled as a library from other applications, so that who knows, right? To get like even better automation of like loading dependencies into a project and those sorts of things. So Google Summer of Code this year has been adapted for the pandemic. It's not going to be a full-time project for a student. It's going to be a part-time project for a student. And so if any one of you is in like, I think it's for university students or like undergrad or grad students. So if anyone of you is interested in applying, or if you know anyone who would like to apply, we will be looking for students. So the way Google Summer of Code works is that you have a bunch of mentors in an organization, and students apply. But then in the end, Google decides how many scholarships you get, like so how many student slots, as they call it, right? So I'm not sure if this project is going to get a student slot in the end, or if we're going to get like fewer slots than we have projects and mentors, and in the end, so those projects might go to the other LabLua projects. But if I get a student slot and if we find a student, so I will be I'm available for mentoring this project in the upcoming Northern Hemisphere summer, which is the Southern Hemisphere winter down here. So Summer of Code 2021, or like Winter of Code for me. So this is a thing, and we'll be looking for interested students wanting to give this a shot. So yeah, this is all that I had for today. I think she was like, I'm super excited. Like I have talked to Patrick to ask if he was available to give the demo here. He said unfortunately he wasn't unavailable, but his work was just so exciting that I really wanted to share with the community, and I think it deserves to be seen, right? The really cool editor integrations that he's been working on, and how smoothly and nicely things are going. So yeah, that's I'm happy to have this recorded now, and that we will be able to share this with a wider audience. Yeah. Anyone else has any other questions or comments? Well, so yeah. So if you don't, then thanks everyone for joining, and see you next time. Probably like again in a month.
Thank you. Bye.
All right. Thanks everyone. Bye bye.